Okay, we have exam review 1. This is a bunch of things that I want you to go through your book, go through your notes if you kept them, and just go over these things. The more you review them, the more likely you are to remember them. So, exam review 1. We have this first one, which if we zoom in here a little bit, says write out the SI units and be sure to include the symbols. So up here in the corner, I put the things that you need to know. You need to know that the meter is the unit for length, and its symbol is an M. Kelvin, K, temperature, thermodynamic temperature. You don't really need to know amps. Time, yes. Candelas, no. Mass, for sure. And mole, for sure. So these are things you need to know for SI units. Also, why do we have SI units? Why do we have them at all? So the why. Remember that we are, the SI stands for International System. Which means that this is how scientists as well as economies do business. They use these units. We all need to agree on what is each one of these things. Okay, so that takes care of number 1. List 5 elements, compounds, and mixtures. The real big goal for, this one's done. The real big goal for this is for you to understand the difference between like sodium and sodium chloride, and salt water. So putting some examples down hopefully will make a big difference in your understanding and comprehension. These are elements. They are unique. They have a number of protons, electrons, neutrons. Sodium chloride has reacted. They are elements that have reacted and form a compound. Both of these right here are pure substances. They have known masses and densities, etc. When you get salt water, this is actually a mixture. And as we're going to be asked in a little bit, there are really 2 types of mixtures as well. There's homogeneous, where they look the same throughout, and hetero, where they don't. You can actually see the parts. Take a moment, write down put this on pause, write down some things. I just got done telling you about homogeneous and heterogeneous, a definition. You should probably find some examples. And in fact, that is what's being asked of you in number 3. All right? Well, I'm going to keep going, just to keep things going. Look through your book and find 10 compounds and put a box around the cation and a circle around the anion. Remember, when we have compounds, in the past we have said, oh, okay, sodium's +1, and it reacts with chlorine, which is -1, and we do the swish, swish, but we don't write ones, so we just come up with NaCl. Well, what I want you to now do is do what we were saying. The first substance is almost always the cation, and the second is the anion. So you need to find 10 of those, do some boxing and circling. Please understand, these are all ionic, and the reason you know that is because I said cation and anion. We don't have that with our recently work that we've been doing with covalent compounds. Now remember, covalent is sharing electrons. Ionic is actually a sharing of electrons. Sharing electrons, not ions. And ionic is actually a transfer of electrons. Please make this clean. Okay, so that should get us through 4. Electrons, protons, and neutrons. You need to look this up in the book. They're going to talk about the proton, its charge, electron, its charge, neutron, and its charge, but also the size of the particles. So if you would, and where they are located in an atom. Very, very important. Energy absorbed and given off. We probably handled that just a little bit ago, probably yesterday even, we said exothermodynamic when we were talking about the heating and cooling curve of water, and we were moving to heat up water or cool down water. All right, this next one here, it demands that you understand how to use ions and make compounds. Here is an example. We're going to say calcium, which is +2, and then cyanide is a polyatomic ion, which is -1. You're supposed to go swish, and this was a 1, swish, and make the compound CaCN2, which means that you have 2 carbons, 2 nitrogens, and 1 calcium. So that should help you answer this one. All right, Dalton, JJ, and Rutherford, and Bohr. Dalton. I think if you looked all these up, it'd be very, very wise. You should put some images down. Okay, JJ, and then this was Bohr. All right, Dalton basically talked about the atom being something like this, but you need to find more things to write down than just that. Rutherford gave us the positive nucleus. So positive nucleus is what I'm saying, but you need to look it up. There's actually an experiment that he did, which is called the gold foil experiment. Write it down. These are be part of the exam review that I give you points for, is when you maybe take up more space than I did and give these 4 summaries. JJ was the foundation or finding of the electron in the plum pudding model, and Bohr was those energy levels and set amounts. All right, good luck with exam review 1, but please do plenty of the details that I just glossed over.